In this video, we'll talk about intervals, their sizes and qualities, how to calculate that. In specific, we'll talk about seconds, thirds, sixths, and sevenths, and what interval inversion is, how to spot it, and how to do it properly. As we've seen before, an interval is the distance between two different notes. When we talked about steps and scales, we dealt with three types of intervals. So we've seen intervals already. We saw that scales were formed from patterns of semitones and whole tones. We saw that the semitone is the shortest distance between two notes, and that the whole tone, the most concise way of defining it, is simply that it is comprised of two semitones, like E to F sharp here. Here I'm giving you some examples, both on the keyboard and here on staffs. We also saw a very particular kind of interval called the perfect fifth, which involved 5 adjacent letter names and 7 semitones, right? Like D to A. There are 5 letter names involved and 7 semitones between them. The two notes of an interval, as you may have already seen from these examples on the staff here, they may be played simultaneously, one on top of each other. So you can calculate the distance, the interval between notes if they are being played at the same time, and that's called a harmonic interval. Or you can calculate the interval between two notes if they're played one after another, like you see here, either in ascending fashion or descending fashion here. These types of intervals are called melodic intervals. Now, a word to the wise, I've mentioned this before, that in music, a lot of the terms are recycled, right? They are used in different contexts to acquire different meanings. We've seen harmonic and melodic. These terms here apply to minor scales, to the variations of the natural minor scale. Though the meaning is similar, there's a very good reason why the harmonic minor scale is called harmonic and the melodic minor scale is called so. Basically, in music, harmony refers to sounds being played at the same time. So it's about the verticalness of music. And melody refers to sounds being played one after another, right? So it's about the horizontality of music, on the other hand, right? So you can see that here, those different planes. So basically, that's what it means when it comes to intervals, being played at the same time or one after another. We refer to intervals by calling them by their sizes and qualities. The size of an interval has to do with the number of letter names involved. We use ordinal numbers to name the intervals: seconds, thirds, fourths, fifths, sixths, sevenths. And then when we get to the eighth, we don't call it an eighth, we call it an octave, which is an ordinal number, but is just a sort of transliteration from Italian, right? That's what eighth would have been called in Italian, ottava. The exception here is the unison, which is a repeated note, right? But it's not called the first. It's called unison, one sound. I have provided examples here, so you can see how we calculate sizes by counting the letter names starting from and including the bottom note, which in these cases here is always the first note because these are all ascending intervals, except the unison here. So the unison, same letter name, C, C. A second, there are two letter names, C and D. Notice how I'm always starting here at middle C. A third, C, D, E, right? 3 letter names. A fourth, C, D, E, F, 4 letter names, and so on and so forth. A fifth is C to G. A sixth is C to A. A seventh, C to B, and then the octave is C to C, 1 octave above. Notice how none of these notes here have accidentals, but even if they did have an accidental, any of them, that would not affect their sizes, because size has only to do with counting the letter names between them. All of these intervals that we've seen, unison to octave, are called simple intervals because they're contained within a single octave. Intervals that are larger than an octave are called compound intervals. They're called compound because you can see them as a simple interval plus one or more octaves, right? These are very common. Compound intervals, despite it, the impression that they might give that they are more rare than simple intervals or that they do not happen very often, they are actually very, very common, especially when we deal with harmony. Say you're learning jazz or progressive rock, and a lot of chords that you have to play on your keyboard or on your guitar have to deal with compound intervals. So you may have seen that already. Like before, these terms here, simple and compound, we've seen that before, right? We've seen these expressions before when we dealt with meter, simple meter and compound meter. But here's an example of how in music we're recycling these terms, and when they have, simple and compound meters have to do with the subdivision of the beat, as we've seen previously. But here, all it means is within an octave or larger than an octave. So a very different meaning here. So we have an octave here. When we have C to D, right, there are only two letter names involved. But you can see that this D is an octave higher than it would have been if this were a second. Therefore, a ninth could be seen as a second plus an octave, right? A tenth, C, E, E. So you have C to E. There are three letter names involved. Same thing. You can see it as a third plus an octave, right? Because in essence, if this were down an octave, this would have been just a regular old third. If you do that for the rest of them, and if you try mathematically to add them up, say an 11th is a fourth plus an octave. Well, if you put 4 and 8 together, that's 12, right? So that doesn't quite make sense. So the reason why they're called like this is because we are counting the same note twice, right? So we're counting the octave twice. So that's why mathematically they don't add up. An 11th equals 4 plus 8 kind of a thing. But that's what it is, right? C to F is an 11th. So C, D, E, F. That is a fourth, and it's an octave higher of where it would have been if it were only a fourth. The other part of naming an interval is the quality. So first part is a size, and we already know that that's calculated by counting letter names. The quality, on the other hand, is calculated by counting the distance between the two notes that you have and the amount of semitones between them. The qualities of intervals are the following: major, minor, diminished, augmented, and perfect. Right? So you can have intervals of different sizes with these different qualities, and we'll see very shortly how to do that. But these 5 qualities are not all applied equally to all interval sizes. Seconds, thirds, sixths, and sevenths receive the qualities of major, minor, diminished, and augmented. Then arguably the unison, we'll get into that in the next video, but definitely the fourth, the fifth, and the octave can be called perfect, diminished, or augmented. There's a good reason why you don't have major and minor fourths and fifths, and you don't have perfect seconds, thirds, sixths, and sevenths, etc. Right? And all that we'll discuss here in terms of simple intervals, notice that all of these are simple intervals contained within an octave. They also applied or are applied to compound intervals as well. So whatever we discussed in regards to seconds also works for ninths, for example. Seconds then involve 2 letter names. These are the possible qualities. A minor second with the shorthand lowercase m 2 involves 2 letter names and is comprised of 1 semitone. An example here is D to E flat. This is an ascending melodic minor second. If you look at the keyboard, that's what you have. D to E flat, 2 letter names, 1 semitone. A major second, on the other hand, is, you can see here the shorthand is uppercase M, 2. That involves 2 letter names, but it contains 2 semitones between these 2 letter names. An example here is B to A. If you look at the keyboard, you have B, and then you have to go over a black key, so that's 1 semitone, and then another semitone to go down to A. This is a descending melodic major second. Notice also that we've seen minor seconds and major seconds previously. A minor second we had called a half step or semitone. These are synonyms, right? And they're very useful in certain contexts. But now we know that a minor second is an even more precise term for when they involve two letter names and there's one semitone of distance. And a major second we've referred to as a whole step or a whole tone. So now you can deduce or infer that the pattern of whole tones and semitones when we talked about major and minor scales, those are simply major seconds and minor seconds. An augmented second, you can see uppercase A2, that contains three semitones, right? Two letter names, three semitones. I've put an example here for you. C to D, that's two letter names, but C to D sharp, still two letter names, contains three semitones, right? C to C sharp 1, C sharp to D 2, D to D sharp 3. That has appeared previously in our videos as that three semitone gap between scale degree 6 and the raised scale degree 7 in any given harmonic minor scale. I've provided here E harmonic minor scale because that's C and D sharp. But really this gap of an augmented second will appear in any harmonic minor scale. It sounds like this in the context of the scale. Right? That. Very common in the literature and also not only in Western music but in a lot of other musics around the world. And a diminished second is very rare. Two letter names, but there are zero semitones involved, like C sharp and D flat. They're usually just written as a unison. Thirds involve three letter names, and then you have minor thirds, lowercase m3, and that has three semitones, and major thirds, uppercase m3 and four semitones there. Augmented thirds and diminished thirds, I put them for reference for you, but they are very, very rare and don't happen very often. Diminished thirds a little bit more often than augmented thirds, but still the ones that we should really focus on, or one should really focus on, is minor third and the major third. At this point also you've been noticing that I've been referring to the shorthand on describing intervals. We use lowercase m for minor, uppercase m for major, uppercase A for augmented, lowercase d for diminished, and we refer to the size with only a number, right? That's very standard, as you'll see throughout. Here is an example of a minor third. I have a bass clef here, notice that, and I have descending intervals here. So I have D to B, right? If you count those notes, say for example to this D to B, you'll find out that there's D to C sharp or D to D flat, one semitone, D flat to C, 2, C to B, 3 semitones. So because there are three letter names involved, D, C, B, or if you count up from the bottom, B, C, D, and because there are only three semitones, that's a minor third. Now, if you want to keep those letter names, but transform this minor third into a major third, you have two options for increasing the distance here between B and D. One, you can make D to B flat by lowering this B into a B flat. Between D and B flat, now you have four semitones. Right? So now this is a major third. On the other hand, if you have that minor third, and you want to transform it to a major third by increasing the distance to four semitones, you can also raise that D to a D sharp, right? D sharp to D1, D to C sharp 2, C sharp to C3, C to B4, and that is a major third as well. Okay, now you may have noticed that a minor third has three semitones, which is the amount of semitones that appears in augmented seconds, right? So when two different intervals with different sizes and different names, qualities, have the same amount of semitones, right? that means that they're going to sound the same to us, but they're going to use different notes. And we have already referred to that as enharmonic. So now we start talking about enharmonic intervals, intervals with different sizes and qualities, but that produce in the end the same sound because they have the same number of semitones in them. So an augmented second and a minor third are enharmonic intervals. I've given you an example here. D to B is a minor third. D to C flat is an augmented second. Notice here how C does not have a black key here, right? So if you will go to the C flat, it's going to be this white key here. So in the end, you're going to be playing the same two piano keys. So you're going to be getting the same sounds, but they're using different notes here. And then, therefore, they have different, they produce different intervals with different names and different qualities. Okay, sixths. A sixth involves 6 letter names. A minor sixth, 8 semitones. A major sixth, 9 semitones. An augmented sixth, which despite its name sounds more exotic but actually is pretty common, has 10 semitones and is enharmonic with a minor seventh, as we'll see. And then the diminished sixth, which is very, very rare, usually written as a perfect fifth, only has 7 semitones. So these 3 are the most important ones: minor sixth, major sixth, and augmented sixth. Here are a few examples for you. Same thing, I'm starting with E and C, and these are harmonic intervals. There are 6 letter names between E and C. If you count E as the bottom and start up, E, F, G, A, B, C. And if you count the semitones between them, right, if you look at the keyboard here, you'll find out that there are only 8 semitones, so that's a minor sixth. If you want to keep those 2 letter names, but turn this minor sixth into a major sixth by increasing the distance to 9 semitones, you can either raise that C to a C sharp, or you can lower that E to an E flat and keep the C, right? 9 semitones. If you do both at the same time, E flat and C sharp in this case, then you're increasing the distance on both ends here. You end up with 10 semitones. And that's an augmented sixth. Very, very common. Sevenths involve 7 letter names, as we've seen already. A minor seventh has 10 semitones. A major seventh will have 11 semitones. Augmented seventh, very rare, 12 semitones. 12 semitones, by the way, is the distance between a note and the note of the same name an octave higher, or in other words, an octave. So there are 12 semitones in an octave. So augmented sevenths are actually really rare. We just usually write them as octaves. But diminished sevenths, on the other hand, are actually pretty common. These are enharmonic with major sixths. So here is a minor seventh, F sharp to E. There are 7 letter names involved and 10 semitones between these 2 notes. Right? If I want to turn, you keep using, this is a ascending melodic interval. If I want to keep using the same letter names but make it a major seventh, I have the same paths as I had before. Raise the top note or lower the bottom note so that the distance is increased to 11 semitones. So F sharp to E sharp is 11 semitones, right? I gotta have that E sharp, even though it's played on a white key of the keyboard, because those are the 7 letter names, right? I can't have that to be an F natural. It has to be an E sharp. Or if I do F to E, that also is a major seventh. If I keep that F sharp in place, right, and E, which produces a minor seventh, and then lower that E to an E flat, then I have a diminished seventh. I only have 9 semitones between these 2 notes, right? And that's enharmonic with a major sixth. Okay, last point. Interval inversion happens when we swap the bottom note of an interval for its top note, reversing the order, or vice versa. Another way of knowing that an interval is the inversion of another interval is by their number of semitones. If the semitones of the two different intervals add up to 12, that is to an octave, then the intervals are inversions of each other. Check out this example here. C to D is a major second. There are two semitones between them, right? If I invert the order here and make D my bottom note, that means that I have to put that C up an octave or the D down an octave, right? Either way, D has to go to the bottom. Here I've put C up an octave. So if D is at the bottom here, and then you have C, then that is a minor seventh. If you count the letter names D, E, F, G, A, B, C, there are 7 letter names. If you count the semitones between them, there are 10 semitones, right? So a major second is the inversion of a minor seventh and vice versa. And then if you count the number of semitones in these intervals, a major second has 2, a minor seventh has 10. They add up to 12, so they are indeed, by this alternative method of confirming that, inversions of each other. Please do notice that inversions are not the same as enharmonic intervals. Inversion means to use the same notes but in a different order, right? A different note will be at the bottom and a different note will be at the, it's the same notes, but the one that was in the bottom is going to go to the top, and the one that was at the top is going to go to the bottom. But enharmonic intervals are different notes that produce the same pitches, the same sounds. So very different thing, not to be confused. Inverted intervals and enharmonic intervals. As we invert intervals, we observe that patterns start to emerge. For instance, every time we invert a second, we get a seventh, and vice versa. That is invariable, that happens every time. Every time you do that, invert a third, you get a sixth, and vice versa, as you can see here. And not only are patterns related to sizes, but to qualities too. When you invert a major interval, that becomes a minor interval. Vice versa. A diminished interval becomes an augmented interval, and vice versa. So here's a list on the left side here of all relevant intervals we've seen in this video and their inversions. Notice how their semitone count, which I've included in parentheses, always add up to 12 semitones. So a minor second inverts to a major seventh, and vice versa, and their semitone count adds up to 12, right? You can see here many of them. And notice that the arrow has 2 points because it is vice versa. You can go either way. Invert a major seventh and get a minor second, or invert a minor second and get a major seventh. Here are some examples here. E to F, there's only one semitone between them, minor second, and then you do F to E, right? F becomes the bottom note, and E becomes the top note. That's a major seventh, right? 11 semitones there. Here's an example of a major third, and then I'm doing this as a descending melodic interval. The B is at the bottom, right? So that becomes B to G, and that's a minor sixth. So you can see that the quality is following that pattern, major to minor, and the size too, third to sixth. Lastly, here's an augmented augmented second, E flat to F sharp. If you invert that, and that's, well, I should actually play it more like this, right? It's a harmonic interval. And if you put that F sharp down an octave, it's a diminished seventh. So you see that augmented becomes sevenths too, and vice versa, and seconds become sevenths. Okay, thanks for watching. Next time we'll talk about the so-called perfect intervals, that is unison, fourths, fifths, and the octave.